Today, we're covering one of the most important applications of derivatives, and that's optimization. Optimization means making the best of any situation. This is how it's explained in the dictionary. As far as we're concerned, optimizing something means making the best of that situation. For example, if you want to optimize your savings, then you can maximize your earnings, your revenue, or minimize your expenses, or both, or a combination of both. If you want, you can also minimize how much you pay for everything, rent and everything, minimize. And I've used the word maximize, minimize, maximize, minimize. What does that mean as far as math is concerned? It means when you're optimizing a situation, the first thing you want is for the derivative to be zero, whatever it is you're optimizing. If the second derivative is negative, then the situation will lead to a maximum. If the second derivative is positive, then that would lead to a minimum. So first find the derivative, set it equal to 0. Okay, let's do an example. In this example, we're going to use the example of a projectile. When you throw a projectile, like a field goal, a baseball, or anything, if you launch it at an angle theta, at an initial velocity v0, this object will go in a curve like this. We're going to ignore air resistance. And the curve will look like this. The range is how far it travels horizontally. And the formula for the range from physics is derived as like this. This is it. R equals v0 squared sine 2 theta over g. G is the acceleration of gravity, and v0 is the initial velocity. So v0 is constant, and so is g. Okay, v0, g are constants. Okay, if you want to maximize the range, like how far this projectile goes, baseball, football, whatever. If it's a football, at what angle should you kick it so it'll go the furthest? Again, we're ignoring air resistance. When you take air resistance into account, that angle is going to change slightly. If you want this to be maximum, R max, so R max occurs when the derivative of R is equal to 0. With respect to what? Let's look. The only variable here is the angle. So it's with respect to theta, the angle. Okay, v0 squared over g is a constant, so we'll leave it alone. The derivative of sine 2 theta is cos 2 theta times 2. Chain rule. This is equal to 0. The only quantity that can equal 0 in this equation is cos 2 theta. So cos 2 theta equals 0. That means 2 theta equals pi over 2 or 90 degrees, or 2 theta equals 3 pi over 2 or 270 degrees. Solve for theta. So theta is pi over 4. Pi over 4 is 45 degrees. Or theta is 3 pi over 4. 3 pi over 4 is 135 degrees. But 135 degrees means you shoot the projectile this way, backwards. We're not. So the solution is theta equals 45 degrees. 45 degrees is the angle which will optimize the range. It means you get the longest field goal possible if you kick at 45 degrees in the absence of air resistance. We're going to do another example. Let's call this example 207 and we'll call the previous one 206. All right. In this example, we have a beam that is deflected. Here's the problem. A beam of length L undergoes a deflection given by this, I'll rewrite it, meters, where x is the distance measured from one end of the beam. Find the position of maximum deflection. So we have a beam. Okay, we're measuring the distance x from one end of the beam, and the total length of the beam is L. The beam, because of its own weight, will get deflected like this. This is an exaggeration. They want to know at what point is the maximum deflection. it's not exactly necessarily in the middle of the beam. So the beam will look like this. So they want to know what is the point at which the deflection is maximum. Okay, this is the end of the beam. So here's the equation of the deflection. If we want the deflection to be maximum, that means we want the derivative of the deflection to be 0. So take the derivative of this. It'll be 12x squared minus 22xl plus 6l squared times 1 minus 0 equals 0. Take out a 2, so that'll give you 2 times 6x squared minus 11xl plus 3l squared equals 0. Divide both sides by 2 so you get rid of this 2, and that'll give you 6x squared minus 11xl plus 3l squared equals 0. Let us factor this. It is 3x minus l, 2x minus 3l equals 0. You can also use the quadratic formula to solve for this, which is okay. So 3x minus l equals 0, or 2x minus 3l equals 0. This means x equals l over 3, and this means x equals 3l over 2. 3l over 2 is 1.5l. What that means is x is at 1.5 the length, which is around here, that's outside the beam. Makes no sense, so that's not a solution. The solution is L over 3. So the maximum deflection happens at 1/3 of the distance. So if it looks like this, this is where the maximum deflection happens. This is L over 3, this is 0, and this is L, and this is 2L over 3. This is halfway. So the maximum deflection happens here according to what we got using derivatives.